Hello and welcome back to SNC1W. We are entering the halfway point of Unit 2 and we'll be discussing the periodic table today in Lesson 3. As a quick review, in Lessons 1 and 2, we reviewed the states of matter, the classification of matter, and the properties of matter. We also reviewed the history of atomic models, the structure of the atom, isotopes and radioisotopes, and calculated average atomic mass. Let's get started with Unit 2, Lesson 3. The learning goals for this lesson include explaining the relationship between the position of elements in the periodic table and explaining different trends of the periodic table. Success criteria, or knowing that you have absorbed all of this lesson's knowledge, can be determined by whether you can complete the following tasks. Ask yourself, are you able to describe how elements are arranged in the periodic table, describe the physical and chemical properties of elements in the periodic table, and compare how atomic radius, electronegativity, ionization, energy reactivity, and metallic character vary in the periodic table. The specific expectations targeted within this lesson include C2.4 and C2.5. So what is the periodic table? Well, the periodic table is a tabular arrangement of all known chemical elements based on their atomic number, electron configurations, and chemical properties. It is a fundamental tool used in chemistry to predict the behavior of elements and chemical compounds. Elements on the periodic table are arranged in rows and columns, known as periods and groups, respectively. The periodic table is organized in a way that elements with similar properties are placed together in the same group. This provides a convenient way of understanding the chemical behavior of an element and predicting how it will react with other elements. The periodic table is an essential tool for scientists and researchers, allowing them to explore the properties and potential applications of different elements. Each element on the periodic table has an atomic number, a symbol, a name, and an average atomic mass. The atomic number of an element represents the number of protons found in the nucleus of its atom. This number determines the element's unique chemical properties and its place in the periodic table. On the other hand, the average atomic mass of an element includes the combined mass of its protons, neutrons, and electrons, providing additional information about its physical properties. Elements are additionally organized in the periodic table based on their physical and chemical properties. By examining these properties, we can classify elements and identify patterns in the periodic table. As discussed in previous lessons, the physical properties of elements include characteristics such as atomic size, density, melting, and boiling points, while the chemical properties of elements include characteristics such as reactivity, electronegativity, and ionization energy. Here is an image of a current periodic table of elements. The periodic table was first proposed by Dmitry Mendeleev, a Russian chemist, in 1869. He organized the elements into rows and columns according to their atomic weight and chemical properties, leaving gaps where he predicted undiscovered elements would fit. His predictions were later confirmed when new elements were discovered that fit perfectly into the gaps he had left. This work on the periodic table revolutionized chemistry and paved the way for advances in atomic theory and the understanding of chemical reactions. So, as discussed, in chemistry, grouped elements share similar properties. These groups are represented by columns in the periodic table. Chemical properties are used to identify materials and reactions that change their identity, such as burning, while physical properties can be observed without changing the substance into something else, such as measuring its length, color, mass, or volume. The periodic table is organized into three main categories of elements. You have metals, nonmetals, and metalloids. Metals are characterized by their lustrous appearance, ability to be hammered or molded into different shapes, and their strong ability to conduct heat and electricity. Nonmetals, on the other hand, lack these properties and are generally less shiny and more brittle in nature. Metalloids, as their name suggests, share some properties of both metals and nonmetals, such as an intermediate ability to conduct heat or electricity and varying levels of luster and malleability. These categories help to classify and understand the properties and behavior of different elements. The periodic table of elements is organized in a way that allows for easy identification and comparison of elements. The elements are arranged both horizontally and vertically, with each row representing a period and each column representing a group. Within a group, atoms of each element have the same number of electrons in their outermost shell, also known as the valence shell. In this example, the group 2 atoms all have 2 electrons in their outer shell. Arranging in this way is significant because the number of electrons in the valence shell determines an element's chemical properties and reactivity. Therefore, elements in the same group tend to have similar chemical properties and reactions. This organization of the periodic table is useful for predicting the behavior and characteristics of elements, as well as for understanding their properties and uses. The outer valence electrons of an atom are the electrons that are involved in chemical bonding. These electrons are located in the outermost shell of an atom and determine how the atom will react with other atoms. Depending on the number of valence electrons, an atom may be more likely to gain, lose, or share electrons with other atoms to form a chemical bond. The type of bond that forms between atoms determines many of the properties of the element. For example, atoms with a strong attraction for electrons, such as the halogens, tend to form ionic bonds, with atoms that have a weak attraction for electrons, such as the alkali metals. This is why elements within a group usually have similar properties because they have the same number of valence electrons and tend to bond in a similar way. Now, if we compare the atoms of different elements within the same bond, we can observe that they have the same number of electron shells. An electron shell is a region around the nucleus of an atom where electrons are located. The number of electron shells an atom has is determined by the number of electrons it has. Understanding the number of electron shells an atom has is important because it helps us predict its chemical behavior and how it will react with other atoms. In this example, the period 4 atoms each have 4 electron-containing shells. Elements are also arranged by groups that have distinct properties. The periodic table is divided into several groups based on the properties of different atoms. For example, the alkali metals are soft, silvery colored metals that are very reactive. Group 1A of the periodic table, also known as the alkali metals, includes elements such as sodium and potassium. Sodium metal can be cut with a knife due to its softness, while potassium reacts explosively with water, producing hydrogen gas and potassium hydroxide. This reaction is highly exothermic, meaning it releases a large amount of heat. Alkali metals are highly reactive due to their low ionization energy, meaning they readily lose their outermost electron to form a positively charged ion. As a result, they are never found in their pure form in nature and must be extracted through various methods. In the following slide, we can see that the level of reaction that alkali metals have with water is organized by least reactive metals at the top and most reactive at the bottom. So, what would you expect from francium? Group 2A on the periodic table corresponds to the alkaline earth metals. Alkaline earth metals are highly reactive and tend to form ionic compounds with nonmetals. They have 2 valence electrons, which they readily lose in chemical reactions to form a positive 2 cation. These elements are important in many industrial and biological processes, with calcium being particularly essential for the health of bones and teeth. As you can see on this slide, Group 2A, which is the alkaline earth metals, are silvery white metals that are fairly reactive, and many are found in rocks in the Earth's crust. Next up are transition metals. Transition metals are a group of elements that are characterized by having partially filled orbitals in their electron configuration. They are located in the center of the periodic table and include elements such as iron, copper, nickel, and zinc. Transition metals are known for their ability to form complex ions and compounds and for their varied oxidation states. They are also known for their high melting and boiling points, malleability, as well as their ability to conduct heat and electricity. Transition metals play important roles in many biological processes as well as in industrial applications, such as catalysts, electronics, and construction. Metalloids, also known as semimetals, are elements that exhibit both metallic and nonmetallic characteristics. They are located along the zigzag line on the periodic table, separating metals from nonmetals. Metalloids have properties that are intermediate between those of metals and nonmetals, such as being able to conduct electricity, but not as well as metals. Examples include boron, silicon, arsenic, and tellurium. These elements have a wide range of industrial applications, such as in the production of semiconductors and alloys. Next up are nonmetals, which are a group of elements found on the right side of the periodic table. They typically are brittle, have low melting and boiling points, and are poor conductors of heat and electricity. Nonmetals tend to form negative ions in chemical reactions and have a tendency to gain electrons. Some common nonmetals include carbon, nitrogen, oxygen, and sulfur. Nonmetals are important in many biological processes, such as respiration, and are used in a variety of industrial applications, such as the production of fertilizers and plastics. Halogens are a group of 5 nonmetallic elements found in group 17 of the periodic table. They are highly reactive and readily form compounds with other elements, particularly metals. Halogens have 7 valence electrons, making them highly electronegative and capable of easily attracting electrons from other atoms. They exist in various forms such as diatomic molecules, ions, and compounds. Halogens play essential roles in many chemical processes and are widely used in various industries, including medicine, agriculture, and manufacturing. Noble gases are a group of chemical elements that are known for their low reactivity due to having a full outer shell of electrons, making them very stable. The group includes odorless, colorless, and tasteless gases at room temperature. They are found in the Earth's atmosphere in small amounts and have various industrial and scientific applications. Due to their inherent nature, noble gases are often used in lighting, welding, and as coolants in nuclear reactors. They are also used in medicine, for imaging, and as anesthesia. The colors produced by noble gases in lamp tubes are a result of their unique electronic configuration. When an electric current is passed through the gas, electrons are excited to higher energy levels. As they return to their original energy level, they release energy in the form of light. Each noble gas produces a distinct color when excited, which can be found on this slide. These colors are used in a variety of applications from neon signs to lighting in scientific instruments. The lanthanide series and actinide series are two sets of elements in the periodic table. The lanthanide series consists of 15 elements, with atomic numbers ranging from 57 to 71. These elements are also known as rare earth elements and have similar chemical properties, making them difficult to separate from each other. The actinide series consists of 14 elements with atomic numbers ranging from 89 to 103. These elements are all radioactive and most are synthetic, meaning they are not found naturally on Earth. Both series are located at the bottom of the periodic table and are part of the F block elements. In summary, for chemical groups, we have alkali metals, which are highly reactive, reacting with water to form an alkaline solution. Next, we have alkaline earth metals, which are soft metals that are also reactive, but not as much as alkali metals. Halogens come next and require only one electron to fill their outer shell, making them highly reactive. Finally, we have noble gases, which have completely filled outer shells, making them almost non-reactive. And with that, we find ourselves at the end of Unit 2, Lesson 2. In summary, the learning goals for this lesson include explaining the relationship between the position of elements in the periodic table and explaining different trends of the periodic table. That's all for today. Bye for now.